Hey guys, Mr. Riz here again to help you out in Algebra 2. So this is going to be our 0.1 day 2. So we're still simplifying expressions here. Our learning targets I guess there's multiple, are that you can use PEMDAS to simplify expressions still. You can combine like terms to simplify expressions. You can use the distributive property to simplify expressions. And then you can also multiply terms together, including variables. All right, so here's the bell ringer, moving on from what we did yesterday. If you guys can go ahead, pause this video, try to see if you guys can try this one on your own, see how well you do. I'm gonna go ahead and get this started in just a second. All right, let's see if you did this. Now, if you remember, what we're going to do is we're gonna substitute or replace all these values here. So we got a is -4. We're gonna put that in parentheses. Then we got -5, a is -4. And then plus 3, C is 2, put that in parentheses. Actually, C is -1. Don't go in order, Riz. Don't make that mistake. And then B is 2, so -2. All right, so going through PEMDAS, please excuse my dear Aunt Sally, parentheses, exponents, multiply and divide, add and subtract. We're gonna do the exponent part first. So there's only that. We're going to do -4 times 2, 16. All right, now I'm just going to continue to write everything the same, even though technically we could start to do some of these things because they're not affected by the others, but let's just take our time, be careful. All right, next we're going to multiply and divide. There's no division, so we got a lot of multiplying to do here. No multiplying there, but we got 3 times 16, that is 48. We got minus 5 times -4, that's -20, plus 3 times -1, that's -3, and then just a -2 at the end. All right, and then lastly, we're going to add and subtract. All right, so just remember here, we've got minus negative, that's like plus positive. So 14 plus 20, that's 34, plus a -3 or -3 would be 31, and then -2. Hopefully you got 29 as your answer. All right, go back and watch this video if you didn't, see if you can find out your mistake. All right, now moving on to what we are going to be working with. All right, we're going to be looking at adding or subtracting like terms. A key thing to like terms is that they have to have the same variable and same exponent. Now, this is not a skill that you guys haven't done before. In fact, if you think about it, in kindergarten, you did the same thing, but you didn't use X's and Y's. You used like animals. So it'd be like, okay, how many of you have this expression here? How many elephants did you have? And you would look and you'd be like, okay, I got 1, 2, 3, 4, 5 elephants. Now, all we're doing is just replacing elephant with an X. How many X's do you have? I would have 5 X's. Now, keep in mind, though, if we have like adult elephants and baby elephants, they could be different things, or, they could be both mammals, even though they look similar. If we have an X and an X squared, they're not the same. So X plus X squared equals X plus X squared. They have to be not only the same variable, but the same exponent. This is technically X to the first power. That's X to the second, not the same thing. So if we look over here, if we're going to simplify here, we're going to look, okay, let's combine our X's. All right, so we look at those here. We got 3 plus -2. Okay, so that's 1X plus 3. So we would have 4X. And then we would move on to our next variable here, which is our Y's, which we have those there. We got 5 and then technically 1Y. 5 plus 1 would be 6Y. Notice we're not changing that at all. And then we technically have non-variables or just straight up integers. We got 4 minus 10, that'd be -6. So that's how that expression simplifies. So let's see if you guys could try this. Oh, actually, the next part is the distributive property. Now, when we have a set of parentheses with a number outside of, or actually any term outside, what that means is we need to distribute or give out that term and multiply it to each part. So when we multiply, we just multiply the outside numbers together. So we got 3 times 2 would be 6. We're going to leave that x alone since there's no other variable with that. Plus, then we'll do 3 times 5, be 15. How many y's we'd have. And then minus 3 times 6 is 18. Then we would want to double check to see if anything inside could combine, but we got x, we got y, and a non-variable. So it's just going to be that. Moving on here. Why don't you go ahead and try this one on your own? So why don't you see if you can pause this video and see if you can handle this expression. All right, we're still going to use PEMDAS here, so we're going to take care of the parentheses. Now, 3x plus 5 does not simplify, so we can't move any further with that. It's not 8x. We are going to then multiply, and distributing is technically multiplication. So 2 times 3, that's 6x. 2 times 5 is 10, and then plus 6x plus 3. So we took care of the multiplication here with our distributive property, and then we're going to add or subtract. All we're going to do when we add or subtract is combine like terms. 6x plus 6x, okay, that'd be 12x's. And then 10 and 3 would be 13. So there's the answer if you did that correctly. All right, once again, let's talk about how do we do this if we have a variable in front. Well, when we have a variable in front, we're going to distribute it just fine. So we'll times this by 3x and we'll times that by 2y. But we got to make sure we understand this. So we have, oh, I started writing the answer. We have 3x technically times 2x cubed. What we have to realize is that we are going to multiply the outside numbers together. So 3x times 2x cubed starts out as 6 because 3 times 2 is 6. Now what technically happens here, we have x times x cubed. That's x times x cubed is x. We times those together or group them together. We would have 4 of them, right? Or x to the 4th. So it's kind of weird. I always think about, okay, if we're going to multiply the big numbers together, but then when we multiply expressions, we're technically adding this 1 with the 3 here. So we would have x to the 4th. So that's the only time when you change the exponent value is when you're multiplying exponents together. All right, moving on here. If we got 3x times 5x, well, 3 times 5 is 15. If we have 1x combining with another x, it'd be x squared. And then in the last term here, 3x times 2y, well, 3 times 2 is 6. If we have an x and a y, those are different variables. So we are just going to leave it as xy, showing that it's just those two variables multiplied together. Moving, grooving along here. So why don't you try this, pause this video on your own and see if you can handle this final expression for today. All right, so going through PEMDAS, we need to make sure that we distribute the 3 here. We also distribute this 3 as well. Actually, no. We could just, we could distribute. Technically, I just noticed here, we could combine those together because they are like terms inside of the parenthesis. We distribute, it's still gonna be okay. I'm gonna distribute because I just like to do that. All right, we got 4x plus 3 times 5x is 15x. 3 times 3 is 9. We got a minus 2x, and then we'll distribute this 3 here. 3 times 2 is 6. 3 times 5 is 15. All right, then we're going to add or subtract. So we're going to combine like terms. We're going to look at our x's first. 4x and 15x, that's 19. And a negative 2 to 19 would be a 17x. And then with our non-variables, we're going to add those together. We got 9 and 6, that's 15, plus another 15. 15 and 15 make 30. Okay. So these are going to be your practice problems that you guys are going to do on your CYU. So remember, you have your paper, go ahead, test them out, and make sure when you type them in, you will have to, like, if you get an answer of like 7x squared, When you type it in the box, you're going to have to type 7x caret 2 to type in x squared. It's the only way the computer is going to be working out. But when you guys write on paper, you know what you mean. All right, guys, good luck on this. If you have any questions, make sure you ask. But thank you for watching. Have a good one.